Hi guys, in this video I'm going to go through this LeetCode 146 LRU cache. So we need to design a data structure that constraint of a LRU cache. So we need to initialize the LRU cache by the capacity, and also we need to write a function get. So we need to get return the value of the key if the keys already exist. Otherwise, if it does not exist, return -1. And also, we also need to write another function put, and what it does is to update the value of the key if the keys already exist. Otherwise, we push a new key value pair to the cache. If the number of keys exceed the capacity, so if the number of keys exceeds the capacity, we have to remove the least recently used, the LRC key, and the function that we implemented, the getting function and also the put function, must be run on big of 1 average time complexity. So immediately that tells me that we need to use the hash map or dictionary to implement those operations. Because if we use a list, that's gonna take more than the big of 1. So let's look at some example in here. So we have this LRU cache, and so we first initialize the capacity. So we have the capacity of 2, and we push the 2 key value pair, 1 1 and 2 2. And after we push them, so you can see they're in the dictionary. And then when we fetched, when we get the data by input the key of 1, so we into the value correspond to that key, and then we insert. So immediately when we fetch the data for the 1 1 this pair, and then that becomes the most recently used, and the 2 2 becomes the LRU, the least recently used pair. And so when we subsequently push another pair, and the LRU get deleted, as you can see. So LRU of 2 is get deleted because we have the constraint of capacity of 2. That's why we can only save the pair of 2. That's why when we subsequently call the key of 2, and it's no longer there. And then at the same time, after the pair of 3 3 get pushed in, and then the 1 1 becomes LRU. And when we insert another pair, and then the 1 1 LRU get removed from the list at the same time. So when we get for 1 1, it's no longer there. And when we get from 3, so it's still there. Get from 4, still there. And this question was asked by very popular for Microsoft and other companies. So so let's dive into see how can we implement it. We need to use a Doubly linked list, because the problem with the dictionary is only there's no ordering for the elements in the dictionary. So in order to implement the ordering, we need to use this Doubly linked list. And so compared to the traditional linked list, there is a two-way links, and one is the prior links to the prior, and another one is the next link to the next node, and also it has a value. We also have the key as well, in addition to this traditional Doubly linked list. So we have basically we have a dictionary. So a dictionary, and the key is gonna be the key is gonna be the key is gonna be the key, and the value is going to be the doubly linked node. So let's implement that. Okay, and we need to initiate a new class. So it's going to be called the doubly linked node, and send. We need the init function, and we need the key. The default key will be 0. The value will be 0. So we need is the self dot key is key, and self dot value is value. And this is gonna two-way. It's a two-way linkage. So self dot ref equals to none at the beginning. Just an initialization. We will put the connection in later in the LRU cache class. And then the next is none as well. So and then now we can jump into so again this DL node is for capturing the ordering, the priority of the node of the key and key value pair. So self dot cap is equal to capacity, and then we need a dummy node. Self dot dummy head equals to a new node, so new DL node, and the key value is going to be 100. And it doesn't really matter actually, just a dummy. So basically the head is capturing everything more recently used, and the tail is capturing the least recently used. So anything is close to the head is recently used, most recent, and the node is close to the dummy tail. It's gonna be the least recent. So and then all the nodes will be stay in between, and then we can see the priority and the frequency of the being used. Which one is most recent? Which one is the least recent? Okay, so need tail, and then we put the connection dot next is equal to the tail, and the tail dot ref equals to the head. Okay, so also we need these two functions to be filled out as well. Yeah, so we'll fill out the two functions later. These three functions. The get function, yeah. So what it does is return the value of the key if the key is already exists. Otherwise, it's returning -1. So how can we do that to check if the key is already there? So if yes, also we need a hash stick self dot cache. Sorry, not hash, it's cache. Cache stick that. So if self dot cache stick dot get key, if that's not none, else means it's none, right? Else we probably don't need this one anymore. So else means it's none. The key does not exist. We return a -1. And put this function right here. It's some helper function that we will figure out later. Put in the cache. Let's see. Yeah, we move node as well. Oops. Here. Okay, so pass this as well. So I will figure out this function later. Yeah, so if the key exists, then how, well, we need to update, right? Update that node. So we need a node to update, and that is just that node, right? Because again, so the value of the dictionary actually is a node. And update most recent, put in that node. So after we get information at the value for that node, and we update that node becomes the most frequently used because we just used it, right? So let's update that. And at the same time, we need to return the value of the node. Okay, so that's that. Yeah, so we need to see the keys there. Update. Yeah, the node to be updated. Also, we update that to be now is most recently used, and then update it and then return the value. Okay, perfect. So yeah, so this is the get function, and now is the put function, and so we have to update the value of the key if the key has already existed. Otherwise, we just insert it and also push out the LRU. So this is the rule for this function. So first thing is to check if the keys already exist or not. So same thing, right? Same if statement, else. And then we need to check the capacity if we have to insert if yeah, if the length of the cache dictionary is greater than the capacity, and that we need to push out the LRU. We will figure out all these if statements later on. So let's get this first. So now we are putting. So in this statement, it is where the keys already exist, right? So in that case, we need to update it. It's similar to this part, right? So node to be updated, and same thing in here. And also, but we instead of returning, we just update the value. Dot well equals to the value, so that's how we can update the value. And at the same time, Oh, sorry. So when we call this function, we call self. Listen. Yes. The value, and this one is already in this dictionary, so we don't have to worry about that anymore. Yep. So that's that. And otherwise, if it's not already existed, we need to create a new node. New node equals to dl node, and key and value is just the input. It's given, right? Key is key, val is value. So we create a new node, and also we do that dictionary thing. So dictionary dot key is equal to the new node. Yes. So and then we insert, right? So we will fill out this function later, and we will, because this one is newly created, so that's why we most recently used cache, right? So we will do a self dot insert. Insert means that we just inserted just right next to the dummy dot head, because it's most recently used. So self dot insert the newly created node. Okay, so at the same time, if we check in the capacity that's greater than the allowed capacity, what we need to do is to remove. So we've got the no dot, there's no to remove, and it's gonna be just right beside the tail. It's gonna be self dot dummy tail dot path, self dot dummy dot path. Yeah, at the same time, we need to pop it off from the dictionary. So self for cache tick dot pop the key. That's why we need to save the key in this DL node. And self dot remove node is the node to remove. Okay, good. So now, I mean, the two big function has already finished. And now we need to finish this three helper function. So insert, basically we inserted to just right beside the dummy head. Yeah. So it is self. So it's a no dot next is equal to self dot, dot next, self dot next. Okay, and no dot path is equal to the dummy head itself, right? Because we basically insert it in the middle. and then self dot dummy head dot next dot path is equal to the node. So it's inserting between on the other side. And oops. Yes, so that's how we insert this insert function, and then remove from the W tail. Yeah. So node to remove dot next next term just that dot next, right? And then we also have a path term dot. Okay, good. Yes, and then stop term next term equals to yeah, it should be next term dot path is equal to this, and path term dot next is equal to that. So basically we just removing from the middle. And then now we do this update most recent. So basically we have to, after we have to do these two functions, is this, just utilize them. So we need to remove it first. And then we need to insert it. And that will become the most recent. Okay, I think that's pretty much it. Yes, it works. And yeah, it looks okay. Yeah, that's my solution to this LeetCode problem 146 using the dictionary, also the double link note. And I hope you enjoyed it. And if you do, please like and subscribe. And hopefully I can see you next time in the videos. Thank you. Bye bye.